Okay, grade 9s, let's have a look at parallel lines. Once again, learn the theory. I'm also sending you the PDF. Firstly, if parallel lines are cut by transversal, let me just quickly point out to you in this diagram where the parallel lines are and where the transversal is. So you will usually have a set of lines which are parallel, given as parallel to each other, and then those two lines will be cut by a certain line, okay, this one here, and that is called the transversal. Okay, and when this happens, there are three circumstances we could possibly identify. First one would be corresponding angles, and they have put them in the same colors for this diagram. So over here we have D, and the same color over here in red is H. So what they form is an F. Remember fun angles? So there's an F that I could form. And the angles, like I always say, in the armpits of this little creature that you could make would be your equal angles. Then I can also identify an upside down F over here. So V would be the same size as F because corresponding angles are equal. And then I can identify an upside down F over here, and therefore E and A would have the same size. And the last thing is I could identify, let me just get a color here. Done. Right, I could identify an F over here, like in the shape of a normal F that we make. So then C and G would be the same size. Now, this would not be true. Neither one of these things would be true if we didn't have parallel lines. If the lines weren't parallel, they wouldn't be the same size each. So here's your statement. You would say that D is equal to H, or C is equal to, now I'm writing in pink, well, that is what it is. Let's have it here. So our statements are over here, possible statements that would be. And then our reason is over here, and that is that they're corresponding angles, but this is very important. This would only be, once again, if we have parallel lines. So this indicates parallel lines. So the corresponding angles are equal because there were parallel lines, and therefore we have to put it as part of our reason. Okay, let's have a look at the next one, the alternate angles, which are also equal. Okay, alternate angles form a Z. So over here in the previous one, we have an F being formed, okay, and then the armpits would be equal. Okay, so corresponding angles are equal. Those would be notes I would let you write down in your books. I would let you draw an F, parallel arms, but the armpits are the same size. Okay, so equal. Then this, for alternate angles, form a Z with those parallel lines, or if you put it sideways or whatever, it would form an N actually with those lines parallel, and they're also equal. The alternate angles are equal. So there are alternate angles which are formed, and they would be there and there, as in alternating from the one side of the transversal to the other. That we have over here as well. Okay, and they're also equal angles. Only if they're between parallel lines. So let's look at this. We can only identify two pairs of alternate angles in this diagram, and these are already highlighted, but they're over here. I can form a Z over here. Okay, and then you'll see the C and the E they are equal, and then I can form a Z that way, which contain the angles D and F. They're named D and F. They would be equal. So our statement over here would be D is equal to F, or C is equal to E. Okay, possible statements that would be for this diagram, depending on what information is given. And then our reason over here is that they're alternate angles, so they're equal because they're alternate angles, and I wouldn't write equal. I would just write alternate angles, and that AB is parallel to CD. So just a quick something here, I would also not write that, just corresponding angles, because we're already saying that they're equal in the statement. Right, just remember that reason may not be written if we do not have the statement or the reason as being parallel. Next example, parallel lines are cut by a transversal, co-interior angles are supplementary. So co-interior angles is formed by a U or a C if you turn it sideways, okay, where those two sides are parallel and or these two sides are parallel. But now I'm not going to make the same marking. I'm going to make that and that because they're not the same size this time around. They are different sizes, but they are supplementary. Okay, supplementary means add up to 180 degrees. Supplementary. Okay, so how many U's can we identify over here? And the first one would be this way, only between the parallel lines. Let me just indicate parallel lines again here. Okay, there's our parallel lines, and your co-interior angles, interior as in between the two parallel lines, will always be between the parallel lines. And then my other pair of co-interior angles is identified on this side. So C and F together is 180 degrees. As you can see over here, C and F is 180 degrees. And then D and E is 180 degrees because they are co-interior angles. Okay, so here's my possible statements once again. Statement. And then the reasons over here, but I would not write supplementary. We already said they're supplementary by saying that in the statement that they add up to 180. So it's just co-interior angles and the fact that co-interior angles only exist between parallel lines. Well, equal, not equal, supplementary co-interior angles. Okay. Now for the converse, it's when a pair of angles are shown or proven to be equal and that they form an F, which is corresponding angles then, okay, then equal and forming alternating angles, which is a Z or an N, or supplementary and forming the U or the C, which is co-interior angles. Okay, supplementary as in add up to 180. Then we can say as a converse that the lines on which they are situated between which they are situated would be parallel to one another. Okay, that's what this little block says over here. Let's just go through it again. The converse happens when you can prove that a pair of angles are equal and forms corresponding angles as in an F, or equal and forming alternating angles as in a Z or an N, or adds up to 180 and forms co-interior angles as in a U or a C. Then automatically, if we can prove that, automatically the two line segments will be parallel. Okay, so have a look at the examples with me. I'm going to write in red. Let me just choose my pen. Okay, so I have in this first example in the diagram two angles which are marked So over here I have x. And the given angle, I always work from the given angle and see what I can relate it to. Well, the only thing here is x. And we must try and form a relationship between x and 115 degrees. And they form an F, which is corresponding angles. Therefore, x and 115 degrees are equal. And they happen to be on parallel lines. So we can therefore say x is 115 degrees in size because they are corresponding angles between the parallel lines AB and CD. Okay, that's all there is to this. Example 2, we once again have parallel lines AB and CD with transversal FG. And we can look at our given angle 80 degrees over here and see how it relates to the missing angle Y. And we can make, of course, a Z. Over here, there's our Z. And what do we know about the Z? That the angles inside are equal. So we can say Y is 80 degrees in size because they are alternate angles between parallel lines AB and CD. Okay, then in example 3 we have the 99-degree angle given to us over here, and we want to see how we can relate that to the other missing angle W. And of course you've already identified that we can identify and produce a upside down U. Okay, so therefore they form co-interior angles, and we know that together they must add up to 180 degrees. So I can then say that 99 degrees and W are co-interior angles which add up to 180 degrees. So we can therefore say W and the 99-degree angle form 180 degrees because they are co-interior angles identified between parallel lines AB and CD. So I'm not done this time around. It's not just one thing. This time it's not just an equal statement. We have a calculation that we have to do. We have to isolate W. So I'm just once again not going to show inverse operations anymore. We subtract 99 from each side, and that gives us 81 degrees in size. Okay, so if you want to, you can write there, for example, minus 99 minus 99, normal equation stuff. And that is how we get to 81. Alright, and then on question 4, or example 4, we have to do with there's now two variables in this diagram. So we've got F and G. The given angle is 75 degrees, and we need to see which of these variables we can firstly relate to the 75-degree angle, and from there, after the one is solved, the other could be solved with that further information. So I can see that F and 75 are vertically opposite angles because this is a straight line intersecting the straight line AB. FG intersects AB. So I can say that they're equal in size. So F is equal to 75 degrees because they're vertically opposite angles. Okay, and then I've got F, and if you want to, as you go, you can write in the sizes here, 75, and now in different colored pens. And now you can relate that angle to the angle at G because they form, oops, that's not a highlighter, because they form a set of co-interior angles between the parallel lines. So I can see that F and G are supplementary. So I can write here that F, which is now 75 degrees, plus G is equal to 180 degrees, because they are co-interior angles, and they're between the parallel lines AB and CD. And now we solve for G by subtracting 75 from each side, and that gives you 105 degrees for the size of angle G. And that's all there is to it. Have a look at the work for yourself to practice all of this. You can do this at your own pace, and please do ask for help if necessary.